I'm going to now try to explain this in more details, and you can compare my understanding of diabetes to what was provided in some of the readily available sources. I'm drawing from some research sources, and I'm also going to draw from some medical textbooks. You could easily pull up any of this information if you need more detailed information about diabetes or anything else on your own, just by going to scholar.google.com and then typing in type 2 diabetes. And what you can see here is a bunch of articles come up. You can sort it by date. You can even go into advanced and tell it to just look for those words in the title. And so you can see it pulls up a 2017 article, but it doesn't always have the full article available. You could even see how many times the article is cited by other articles, and an article cited more times is probably something that other people think is noteworthy. So if you're looking for more advanced information, something that's been reviewed by other individuals to make sure that it's authentic and correct, Google Scholar is a good place for that information. But you do need to know some more advanced information about what you're looking at first, so that you can understand these articles. Some of them are written in jargon that makes it difficult to understand, and others are not. This is an article that I found just using Google Scholar. It was published in Lancet, and I think it really has a good explanation of what goes on in diabetes. Just to summarize some of the normal function before I go into detail about diabetes, and we can then compare that to what we've read about it already. In normal function, your body uses sugar as fuel for cells. So after you eat, that sugar goes into cells, and cells are hungry, and in order for them to eat that sugar that's in the blood, they need insulin. So insulin gets secreted by the pancreas, by the beta cells in the pancreas, and the cells use that insulin in order to eat sugar. It's kind of like I said, the smiley face eating, the insulin is the spoon, and it feeds them that sugar. Now, anything that's remaining in the blood beyond a certain amount, an excess amount, that goes into other storage areas like the liver. And the liver converts that sugar into a stored type of product. It's called glycogen, and glycogen can be broken down later on, if you're fasting, into sugar that your cells can use, again, for food. How does your body know that it has a meal coming along? Well, your intestines actually communicate with your pancreas, and other cells communicate with your pancreas, and your nervous system and your brain communicate and make sure that the right amount of insulin is being produced. But the pancreas also produces something else, which is called glucagon, and glucagon actually acts sort of in the reverse way. It tells your liver to take some of the stored sugar and make it into regular sugar. And an example of a time you would need that is when you're fasting. So let's talk about diabetes, type 2. I'm going to go further into detail now. Diabetes is a group of disorders. One of those is diabetes type 2, which we're focused on because that's the most common type in adults. There's a progression of disease that takes place, going from normal blood sugar handling in your body to abnormal to diabetes. So normal blood sugar in your body should probably be around 100 milligrams per deciliter. And when you have diabetes, it's probably around greater than 126 milligrams per deciliter. So you can do a fasting blood sugar, you can do a blood sugar that's taken after somebody eats, or you could just test something called hemoglobin A1C in order to tell whether somebody has diabetes or not. So that's the way that we screen individuals for diabetes. It's important to screen individuals for diabetes because in most cases people don't have symptoms, so you want to test them without symptoms. And also because, according to epidemiological research, many people may have diabetes for 10 years or more before they're diagnosed. The diagnosis criteria, which I'm showing over here, there's fasting blood sugar that can be done, and normal would be less than 100, greater than 126 is diabetes, and in between is prediabetes or just impaired blood sugar handling. There's the OGTT test, which is a glucose tolerance test or oral glucose tolerance test that's often done in females to detect gestational diabetes, which means diabetes that takes place when you have gestation or pregnancy. And greater than 200 is a mark where you would be considered to have gestational diabetes, which is also a risk factor for diabetes. And then there's A1C, which is, or HbA1c, which is a measure of hemoglobin that is glycosylated. What is that? So you have red blood cells in your blood that carry oxygen. How do they carry that oxygen? Using hemoglobin. So you can think of red blood cells as carrying these knapsacks around, and the knapsacks have oxygen in them, and they're bringing them to different parts of the body and to other cells and to organs, to other parts of the body, like your heart and or major organs and other cells. So when you have blood sugar in your body and it's too high, or even at any level, when you have blood sugar in the body, some of the blood sugar ends up sticking to hemoglobin. And you can think of that as kind of taking up space in the knapsack. If there's too much of it, it may take up too much space and be bad for you. And in fact, it can impair the way that hemoglobin functions. What's good about A1C is it's a measure to take a look at how the average blood sugar control was over the last 3 months. Fasting blood sugar and glucose tolerance tests are just looking at one point in time. With A1C, it's actually looking at a percent, how much of hemoglobin has got blood sugar stuck to it, or is glycosylated. And so it looks at that percent, and if there's too much, it's a bad thing, and it approximates a certain average level. So somebody with a HbA1c of 10 is estimated to have a blood sugar level on average of around 240. And so greater than 6.5 is considered diabetes, and less than 5.7 is considered to be normal. The body wants to maintain equilibrium and balance. And to do that, with blood sugar after you eat, it uses various hormones. It wants to maintain this balance and keep blood sugar in a tight range, primarily so that your cells can get energy from their primary food source, which is sugar. And also so that they can eat right away, and also so that they can store energy for the future. So when you eat, insulin is one of the main hormones that is used to signal to the cells that they can eat, and kind of you can use that example, like insulin is that spoon that's feeding the cells the sugar. It's also telling the liver to store blood sugar for the future, and it's also signaling to the body to store other things like fats and protein. But besides from insulin, the body and the pancreas, which secretes insulin via the beta cells, is relying on other signaling, other metabolic signals, other hormones. For example, glucagon, it relies upon, and glucagon is secreted by the alpha cells in the pancreas, and it actually, in a state of fasting, will tell the liver, for example, to start taking out some of that stored sugar and increasing the blood sugar levels so that your cells can eat. At the same time, glucagon levels need to be suppressed when insulin's being secreted. So you don't want, after you're eating, to have your liver increasing the blood sugar. So glucagon shouldn't be getting secreted at that point in time. So if you're exercising, your brain has this sympathetic drive, and it's telling your body to produce more insulin, to make more sugar and energy sources available. It's also relying on signaling from the stomach, where the stomach is secreting out certain hormones like glucagon-like peptide, GLP-1, and other what they call incretins, so that your stomach is signaling, hey, we're eating, we need to have more insulin available. And so all of these are kind of working together in order to produce this homeostasis with glucose. There are 4 main features of diabetes type 2, including impaired insulin secretion and insulin resistance. So your pancreatic beta cells are not secreting enough insulin. That's one thing. And your cells are not responding to insulin as they should. So they are just not taking in as much glucose. The cells are not taking in as much glucose as they should in response to a certain number or certain amount of insulin. And another two things that are going on include that your liver is producing too much sugar. Stored sugar that should normally not be getting released by the liver is getting released by the liver. And also, your body is not metabolizing fat properly. So those four things are all contributing. The first two are probably more responsible than the latter two, but these things vary in individuals, and they tend to take place over the course of time. The last thing that I mentioned is abnormal fat metabolism. Individuals who are overweight with a BMI over 25 or obese with a BMI over 30 are particularly susceptible to diabetes because of the last thing I mentioned, which is abnormal fat metabolism, which can contribute to diabetes. All of this takes place over the course of time. It's a progression. It's a progression that starts with no symptoms to individuals who are having problems feeling their toes or having heart attacks or strokes because they've had diabetes and it's ravaged their body. But in the very early stages, before there are symptoms, what takes place is that when you eat, your blood sugar remains pretty much normal, but your cells are developing what's called insulin resistance. They're becoming resistant to insulin, and for a given level of insulin, they're not taking in as much sugar. So your body is just trying to keep homeostasis, and what it's doing is secreting out more insulin from pancreatic beta cells. The next thing that happens is that as this insulin starts to increase, this what they call this compensating hyperinsulinemia, some people just cannot sustain putting out enough insulin. The body can't keep up with the levels of sugar, and the beta cells actually start dying. So they're dying off, and also they're not functioning properly. So not enough insulin is actually getting produced in order to handle the sugar. That's when you can start to see abnormal blood sugars after eating. You still wouldn't see the fasting blood sugars be abnormal at this stage of illness. So testing fasting blood sugar, it's not going to catch this. Your body is still doing a good enough job to compensate. However, insulin levels are just not high enough. And over time, this insulin resistance increases. And the beta cells, they're being stressed and they're dying and they're not functioning properly. And the insulin response is just not enough to get enough glucose to the cells to eat. So what happens next is that your liver starts to compensate, and it starts increasing its production of glucose from stored glucose sources. This is when you would see more of the fasting blood sugar levels be elevated and is more likely to approximate a diabetic state. Over time, as there's more insulin resistance and more beta cells are dying and less secretion is taking place of insulin, diabetes gets worse and blood sugar levels continue to elevate. What I just explained is some of the pathophysiology, but it doesn't get down to the reasons. We know that there's this progression taking place where individuals start off with some level of insulin resistance and end up with a dysfunctional liver, a dysfunctional pancreas, and we don't have answers as to why that happens. So the reason why we think it does happen is due to two common factors, nature and nurture. Thinking about nature, we have genetic studies that show when one identical twin has diabetes type 2, the chances of the other one also having type 2 are between 70 and 90%. Another risk factor is family history. So if you have a first-degree relative like a mother or a father, sister, brother, or child who has diabetes, you're at an increased risk. And studies have shown that if both parents have diabetes type 2, the likelihood of also developing type 2 is in the ballpark of 40%. What's probably happening in these individuals is that they are starting off with beta cells that are just not as good as an average person. So their genes their genes are coding for beta cells. They're just don't function as well. So they already have some sort of diminished capacity to start with. Other individuals who are at high risk probably also have diminished beta cell function to start with, and that includes women who've had gestational diabetes or polycystic ovarian syndrome, and also individuals who are overweight. But that kind of goes into environmental as well, because what makes you overweight is what you eat. Another issue is age. So individuals who are older than 45, it seems that just their beta cells don't work as well. So just this inherent decline in beta cell function by genes is one explanation for why you would have some sort of impairment taking place. The other thing is environment, and part of that is what you eat. And if you eat diets high in fat and saturated fat, that's likely to lead to obesity, and that's potentially a cause. So why would that happen? Simply, too much sugar, too much glucose, too much lipids or cholesterol in the blood are in and of themselves toxic and cause damage to beta cells and other cells in the body. We know that glucose can also damage things like nerves. And so this circulating glucose actually can get absorbed into beta cells and at high levels just start to destroy the beta cells and impair their function. And we also know that it impairs the way that hemoglobin functions and its ability to carry oxygen to tissues around the body. So one thing is that the glucose in of itself being at high levels causes disruptions to the beta cells and causes also cells around the body that are responding to insulin potentially to also have dysfunction. Another one of the risk factors for diabetes is one of the environmental factors, is being overweight. And when you're overweight, you have more fat cells, known as adipocytes. And these adipocytes release free fatty acids or fat into the blood. And also they release something called adipokines, from the word adipocyte or fat cell, adipokines into the blood. Both the free fatty acids and the adipokines can impair cells and cause them to be resistant to insulin. So being overweight plays a large role in the development of diabetes. Also, free fatty acids causes the liver to produce more glucose, and by doing that, it ends up increasing the overall sugar levels, which in the end, as I mentioned, glucose has this toxicity, and that causes damage to the cells in the pancreas. So this overall state is going back and forth in kind of this cycle where worsened blood sugar causes worsened function of control of the sugar, which then leads to even higher levels of sugar and other problems taking place in the body. And ultimately, this glucotoxicity causes a lot of problems throughout the body. Another cell that appears to be damaged, which is also in the pancreas, is the alpha cell. So that alpha cell is responsible for sending signals to the liver to increase glucose production. So anytime glucagon is elevated, the liver's starting to produce glucose, and when insulin is being secreted after you eat, for example, hopefully glucagon is being suppressed. And if that fails to be suppressed, then you end up with even higher sugar levels, and that's what tends to happen in diabetes, and it's likely a result of some of this glucotoxicity taking place as well that's causing damage to these alpha cells. Another thing that happens with elevated blood sugar levels and cholesterol levels is that there seems to be promotion of a state of inflammation. And this state of inflammation interrupts the normal signaling that takes place in the body that helps the pancreas communicate with the liver and the intestines so that proper homeostasis is taking place. Finally, we see a large number of reactive oxygen species that take place in individuals with diabetes. These are circulating radicals, which you may never have heard of, but what I'm sure you've heard of are antioxidants. And antioxidants work against these reactive oxygen species. These reactive oxygen species are involved in a diversity in many different things, including the development of cancer, including the development of inflammation, aging, and atherosclerosis. And it appears that individuals with diabetes have this predominantly because they have these high levels of glucose, and this glucose promotes this inflammatory state and one in which these oxygen radicals are causing damage to the body and likely causing damage to the pancreas and other cells that are responsible for maintaining blood sugar in the body. I'm not going to go too far into detail about the complications of diabetes, but the primary ones are cardiovascular, where individuals can develop heart attacks and strokes, and neurologic, where individuals could develop neuropathy, which is damage to nerves and may experience pain. They may lose sensation. There's also the potential to damage other organs like the kidneys, and individuals who end up with end-stage renal disease and require dialysis are often individuals who have diabetic disease of the kidneys. Diabetes can also affect your eyesight and your eyes. It can make individuals experience miscarriages by compromising blood flow to a placenta. It can also cause sexual dysfunction and a whole host of other problems. Not going to go into the treatments, but the most important thing to do is to have primary prevention if that's possible, which is preventing ever getting the disease. And the way to do that is by exercising and watching your diet, maintaining a proper diet without eating too much sugar, which, as I hope you have garnered from this video, is not a good thing and can cause a lot of damage to your body. So hopefully I've given you a good overview of what diabetes type 2 is. I started off looking at some of the web resources so you could see what type of commonly available information there is, and then I progressed on to providing some information from some medical sources like research articles as well as some medical textbooks. I'll provide links to some of these sources below, and please subscribe to my channel if you think this was a good video. If you have any comments, please let me know. Thanks for watching.